As this complex building evolves, we again give way from massing to building elements. Here you can see a fairly detailed Revit model with an open parking ramp with sloped floor surfaces, and the first time that we create an energy model, we see it's sort of a mess. There's not actually a fully enclosed building. And upon further investigation, we see that this sort of loose early model had some fairly large gaps between the floor and this sloped surface, so essentially there was a hole between the inside and the outside that was too big. Here we made some adjustments to move the floor closer but not yet touching the exterior, and Revit is able to deal with smaller gaps, but very large gaps can be a problem. So again, here's a fairly detailed Revit model with this partially open air parking ramp. There's a retail down on the lowest level and then office space in the tower part. There's a underground tunnel connecting an adjacent building. I had to fill that in with a wall, again to plug up any large holes that might occur. We'll take a look at the energy settings dialog. Go into the advanced settings and notice that now that we have a more detailed model, the window to wall glazing ratio can be set to 0. We're going to create an energy model. The main competitor to Insight is Sapphira by Trimble, and Trimble isn't able to actually create an energy model from this particular design because it's too complex. So just mentioning that as a way to understand some of the value proposition here that I'm advocating with Autodesk Revit in the Insight workflow. Here you'll notice I narrowed down some of the analytical surfaces to just spaces, which this entire building now it was automatically thermally zoned. The 15-foot thermal zone around the perimeter, and then one remaining zone in the middle per floor. Here's the shade surfaces, the existing buildings we'd expect to see, and some of these other elements are just layers of walls that ended up getting turned into shade surfaces. Some embellishments on top of the main wall. But if the entire building was all gray and showing up as a shade surface, that would be bad. So there's the glazing. It's good to take a good look at your energy model before you push it out to Insight to make sure that it was properly created. This will save you a lot of time. Notice that some of these floors have automatically been translated to above grade or below grade. Now we'll turn everything back on. We can again look at the schedules that got created. All the surfaces. Just a little common sense double check we can do to make sure that the percentages look about right. Next we'll generate an Insight run. Because the energy model was already created, it's just we're going to use the one that we have already visually inspected, but you'll always get reminded to recreate the energy model again, because if you change any input or your building location or true north or geometry, none of that will show up in the run unless the energy model has been manually deleted and recreated. So now we're going to add that run that automatically gets put into the uncategorized section to our project. And now we can compare the massing to a much more detailed version of the model. And you can see that the numbers they're different, but pretty close, all things considered, when you consider the simple mass as compared to the time that it took to create the more detailed Revit model with building elements. So in a lot of cases, you can, even on a project that has already been started and nobody's done any energy modeling on, you can create some large mass elements and run an analysis based only on those masses. Look at a few of the results from this run. Notice that several inputs have been specifically dialed in now. The window to wall ratio should change to match the actual design. So this is where you have to be a little careful when you're applying scenarios to multiple runs. Just take a quick look at some of these remaining inputs to see what they're set to. In this case, this building doesn't have an opportunity to rotate given its urban context, so we'll just set that to 0. And then we can save this current scenario so these settings can be retrieved later if a different project-wide scenario happens to be applied and we want to come back and see these specific settings. And that's a quick look at a more complex building based on Revit building elements.